The BERT model is a really popular model that's being used by a lot of companies and other organizations researching conversational AI and deploying it.
Hi Renee, do you have any questions?
How many CUDA cores is that?
Jetson Nano has 128 CUDA cores.
When you talk to a computer, a whole bunch of different things have to happen. First, the computer needs to actually transcribe what you said. Then those words need to go into a language model like BERT that's going to figure out what you meant and then generate a response.
Great, I will charge it to your account.
And all of those things take time and add latency. And latency makes the interaction slower and not feel natural. So every millisecond of latency that we can shorten in this pipeline is going to make the user experience better. One of the things that we found very helpful is vastly larger language models that are trained on vastly larger amounts of text. The problem is that these models are so large that they're difficult to train and they're also difficult to deploy. So NVIDIA has really made the training procedure for these large language models much more efficient, and we can now train one of these large BERT models in about an hour, which is faster than anywhere else. Researchers are constantly improving their models in order to make conversational AI better, and so the time it takes to train a model translates into the research progress. The quicker we can train a model, the more models we can train, the more we learn about the problem, and the better the results get. Until recently, it would have been crazy to think about deploying one of these huge BERT models in production in a latency-sensitive application because it would be just too slow. But we've been able to take BERT, run it through TensorRT, and now inference time is only 2.5 milliseconds. This means that these applications can now feel natural. So by making BERT faster, we're actually making a whole class of models faster and more useful for the whole industry.